Here we have 2018 Electricity and Magnetism, question 2. This is very similar to the ones we were doing on Friday, which I told you we would do a lesson on. So here we go. We have an experiment set up where they have made a parallel plate capacitor with aluminum foil. Cross-sectional area of 0.06 meters squared. They're putting multiple different pieces of paper in there. You can see here 500, 400, all the way down to 100 sheets of paper. Their associated distance between them, and the capacitance that they're measuring on a multimeter, all in hopes of finding the experimental value for the dielectric constant of the paper they're placing in there. So what they're asking you to do is they're asking you to find, you got to read this carefully, indicate which property should be graphed to yield a straight line whose slope could be used to calculate the numerical value for the dielectric constant. So all of those are very important. First off, means that we have to have a formula that has the dielectric constant in it, obviously. We also need to choose a formula that has the data that they're collecting in it as well. So capacitance and distance between the two pieces of paper. So here's our formula. The next thing they made it a point to say was they need it to be a linear equation. So we're going to start with, we're going to go right with y equals mx plus b. And what we're going to do is we're going to try to manipulate this formula, or in this case we don't have to do much manipulating, to get this to the point where we could put one of these variables, one of the given variables, one of the calculated variables I guess, on the y-axis, one of them on the x-axis, and then in our slope we have to have our experimental value we're looking for. So here we have c. So I can allow c to be my y. That'll be on my y-axis. Check. Now, we're going to rewrite this a little bit. Kappa epsilon sub 0 a 1 over d. Now, why am I doing that? Well, I want my slope to contain my experimental value that I'm looking for, and anything else that might be in there I need to have to be a constant. Okay? So my m is kappa epsilon naught a. And this is peculiar, but not terrible. My x, so what I'm going to put on the x-axis is actually not d, but 1 over d. And now, because this works out nicely, and again, concept meets real life here. If I have 0 paper between those two pieces, then I have obviously 0 capacitance. So as that gets to 0, this 1 over d factor gets to 0, it stands to reason that my capacitance would be 0. Okay. So on my paper over here, I'm going to say that on my vertical axis, I'm going to put c. On my horizontal axis, I'm going to put 1 over d. Okay, so I'm going to come over here on my chart. I'm going to put 1 over d, which means my unit would be 1 over m. And I'm just going to put in the values, which I took the time to put together before. So it's 22.2, 27.8, 37.0, 55.6, and 100. Okay, so done with that part. Then it's a matter of graphing it. Now, the questions they're asking you obviously aren't asking you to do the graph, but it doesn't hurt for us to discuss the graph here anyway. Mostly because what they did ask you to do is describe how you would graph it, what you would graph, things of that nature. So we're going to put c here, and we're going to put 1 over d here. Now, the units for 1 over d are simple. We talked about them already, 1 over m. Now, c, technically farads, but what I'm going to do is I'm going to do the little trick here. I'm going to say farads times 10 to the negative 11, which will eliminate, because if you look over here carefully, each one of these is times 10 to the negative 11. So instead of us having to do that scale, we could just do a scale from 0 to 25, let's say, because there are 25 boxes. We do 0, 5, 10, 15, 20, 25. That would work out nicely. Now, I obviously am not going to sit here and make you watch me do a graph. So I've kind of stolen this right off of the key. We have over here the capacitance in farads times 10 to the negative 11. We have the thickness, they're calling it down here. It's 1 over D, which is 1 over M. And then they found the slope. So they just went, grab a different color. They just found 2 points where it comes nicely through an XY axis. So they went to 17, or they went to 80 here, boop. And they went to 32, which is here, boop. And they found a slope. So they went down 17, from 17, again, times 10 to the negative 11, to 8. And then from 80 back to 32. Okay, obviously it's written much nicer down here. And you end up with this thing, this 0.19, and the unit's wacky too. It's farad meter. Okay. Now, we all know that there's really no useful thing that's called a farad meter, but we're not done. We're looking for the slope, or we found the slope rather, but remember the slope is not our dielectric constant. Our slope is the dielectric constant times epsilon naught times A. So we're going to solve for kappa, for the dielectric constant. It's going to give you slope over epsilon naught A. And then we're going to put this on top. Epsilon naught, again, on your reference table, so shouldn't be too bad. And this was a given value. And you end up with, given their exact numbers, 3.58. Now, interestingly enough, if you're good with your calculator, you could use the linear regression function on your calculator and you get 3.52, which is similar. Obviously, your number might not come out to be exactly 3.58. I suggest, I implore that you guys sit down at some point and do this on your own to make sure you could get these numbers or similar numbers if you wanted to. It might not come out to be exactly that. It might come out to be 3.5, 3.6, 3.4, but should be in the realm of this. Okay, so that was an electricity and magnetism one. Let's just really quick try to go through this one. Now, this one was a little bit different because there was a part A that discusses kind of almost an experimental issue. So in this issue, with this issue, it says that the student notices that basically the electromagnet that's holding the sphere and letting go of it before the timer starts is not letting go immediately right away. So not the idea behind the lesson, so I'm not going to spend a lot of time on it, but simple answer would be if it didn't fall as far in the same length of time, then your experimental value that you would get under those conditions would be less. But I digress, because that's not what we're looking for. What we are doing is we're going to say they took measurements of different heights, so they basically said, I'm going to put it at different heights, I'm going to measure the length of time it took to fall in each situation, and they say here, indicate below which quantity should be graphed to yield a straight line. So again, that straight line thing, so y equals mx plus b, whose slope could be used to calculate numerical value g. So we need to find a straight line, and we need to find a formula that has distance, time, and g. Now, what you'll realize when you start looking for these is it doesn't seem super easy to find, but it's really hiding right under your nose. We got this guy. Okay, so D equals VIT. Now, VI is 0, so that'll make our life a lot easier. So we got D equals 1/2. This is G, remember, T squared. So this, we can put on our y-axis. That'll be our height. 1/2 G will be our M. And then the only kind of weird thing here is that T squared is our X. And then again, VIT would have been our plus B, but there is no plus B. All right, so I took the opportunity in this case now to make the next column, the next row rather, which would be T squared, which remember the units would then be second squared. I put the numbers in here for you. Okay. And then again, for the sake of time, if nothing else, I took this right off of the key. So this would be the data points that we just came up with, graphed. Now, remember, simple answer is they put it as height in meters. If you did distance in meters, I don't think they're going to give you a hard time. But this is important. It says height in meters. So when they start asking these questions, especially if they're asking you to write this out, type this out, you really have to be mindful. If they're asking for you to describe units and what the units would be and why, you have to be mindful. This one's easy. This one is very easy to overlook. This one here would be very easy to overlook because you're just thinking you're putting seconds down there, but you're really squaring that time, so you have to be squaring the unit. Okay? Now, here I kind of compacted it instead of breaking it up into different pieces. So once again, you would use the graph. You'd find the slope, which in their eyes is 0.496, or if you did linear regression, 483. And then you're going to take advantage of the fact that, remember, the slope wasn't g, the slope was half of g. Right? So now if the slope is half of g, to get g, you have to multiply the slope by 2. So you can take that 4.96, multiply it by 2, and you're going to get 9.92. And again, they did the linear regression here. So that's that. And I know it seems a lot easier when I did it here than when we did it on Friday, but I think a lot of things happened on Friday. I think we all got bogged down by how complicated they seem to be trying to make it. But at the end of the day, this is how we're going to have to do it. Note that I didn't necessarily go even by the way they were asking the questions. I knew what we had to get to, which is kind of what you guys are going to have to do. You're going to have to read the whole question as a whole, know what you have to get to, and as I did here, I highly suggest you start by finding the formula, trying to manipulate it and work it into y equals mx plus b, assuming they ask for a linear relationship, wherein two of the variables they give you, or two of the experimental variables that you're kind of deciding on, are your y and your x, and then to make sure that the thing you're looking for is part of your m. If there's a plus b, there's a plus b. There might be situations where there is a plus b. So be it. So your assignment is going to be two other questions just like this. It's going to be another mechanics question and another electricity and magnetism question. We're going to have you do those, or I'm going to ask you to do those. I'm going to ask you to do these on, get these done for Friday. You still have the other assignment I sent you on Friday, which is to pull apart the mechanics test, just like you did with the electricity and magnetism test. The difference is this Wednesday, I'm actually going to send you out the answers to that, so you have a chance to look it over, make sure you knew what you were doing, and then you can come in at least with specific questions. All right? Wednesday, I'm also going to post another short little review lesson, whether it be done by me. I might see if I can find a better one done on YouTube, but we'll see. Trying to raise my game a little bit here. And then we'll talk on Friday at 1 o'clock. All right? I'll talk to you guys soon.